Alright, you guys, today we're doing Understanding Exponents, Unit 2, Day 1. Our objective is I will be able to apply exponent rules related to zero and negative exponents. So our first vocabulary word is the word exponent. The exponent of a number says how many times to use that number in a multiplication problem. So here, if we have 3 to the second power, 3 is our base, and our exponent is a number 2. Now we can see here that 3 is the number being multiplied, and the number of times that it's being multiplied is 2. Now we know that 3 times 3, or 3 squared, is equal to 9. So for this first teacher example, if we have the exponent 4 to the first power, 4 to the first power here, that's telling us we're going to multiply the number 4, which is our base, 1 time. So we know 4 is 4. Now when we do 4 squared, and we're multiplying the number 4 2 times, 4 times 4, we get 16. Now if we do 4 to the third power, we're doing 4 times 4 times 4, and you end up with 64. And then 4 to the fourth power is 4 times 4 times 4 times 4, which gives us 256. So then 4 to the fifth power, 4 times 4 times 4 times 4 times 4, if we pull out your calculator, you end up with the number 1024. So take a second and fill out your student example. Now there's a special rule called the zero exponent rule, where anything raised to the 0th power equals 1. Now, that seems like a kind of a weird rule, so let's figure out why that's the case. And I want to start right here. To go from 4 to 16, you have to multiply by 4, right? Because we're adding another 4 that's being multiplied. Similarly, to go from 16 to 64, you're multiplying by 4. And then from 64 to 56, you're multiplying by 4. That means if you're going the other way, from 256 to 64, you would be dividing by 4. From 64 to 16, again, you're dividing by 4. And then 16 to 4, you're going to divide by 4. So if we wanted to do 4 to the 0th power, we would do 4, and then we'd divide by 4 again. Now 4 divided by 4 gives us 1. So this proves that 4 to the 0th power is always equal to 1. And that's the case for any base. So if we had x to the 0th power, that would equal 1. We would have 1,000 to the 0th power, that would equal 1. You could have 12 to the 0th power, that would equal 1. You could have negative 3 to the 0th power, that would still equal 1. And this is a really powerful and a really important rule to keep in mind. Now, let's continue to extrapolate this rule and figure out what happens when our exponent values become negative. Now, from the previous, what we just talked about, 4 to the 0th power, we just said is 1, right? Because to go from 1 to 4, we're multiplying by 4. From 4 to 16, we're multiplying by 4. From 16 to 64, we're multiplying by 4. When we're going up, we're dividing by 4. 16 to 4, we divide by 4. From 4 to 1, we're dividing by 4. That means we would have to, again, divide by 4, which would leave us with 1/4. So when we take 4 to the -1 power, what we're actually doing is making it into a fraction. So we're going to do 1 divided by 4 to the first power, which is 1/4. Let's try it again. So you take 1/4 and we divide it by 4. You end up with 1/16. Now what you'll recognize is that the 16 here, and there's a 16 here. And you can keep in mind this is a -2 and this is a +2 exponent. So as a multiplication problem, what this means is we make it a fraction, and then again 4 is being multiplied, but this time in the denominator twice. So we know that 1/4 times 4 is equal to 1/16. So if we're going to do it one more time, divide by 4, then you would get 1/64, right? And then your multiplication would be 1 divided by 4 times 4 times 4. So take a second and fill out your example below. Instead of a base being 4, your base will be x. Now let's utilize the rules that we just learned to simplify expressions. So here we're given 3x squared, y to the -3rd, and z to the 0 power. I'm going to break this up into 4 separate terms that are being multiplied together. First is our constant 3. Then we have x squared, y to the -3rd, and z to the 0th power. And I'm going to think about two things. One, is there anything else that is a like term to this? And second, is there any rule that we just learned that we can apply? So here, our first term is 3. There are no other constants, and there are no rules that we learned today that helps us deal with this 3. So we're just going to leave it. X squared is actually the same. We haven't learned how to simplify it further, and there are no other terms with an x or a squared. So we're going to have 3x squared. Now, negative exponents, though, we actually have learned about. When we have a negative exponent, we can make it into a fraction. And so what we can turn this into here is 1/y to the 3rd. So if it's 1/y to the 3rd, that means we're going to make this part a fraction, and then our y to the 3rd is in the denominator. It's being multiplied by 1. And what we know is that anything to the 0th power is also equal to 1. So here, this is going to be multiplied by 1. So altogether, you're going to have 3 times 1 times 1, which is still 3, x squared over y to the 3rd power. And that is our simplest form. Take a second to try your student example. Now in the summary section below, I want you to write one sentence that summarizes the main idea of today's lesson and one question that you still have about this topic. So, summary and a question. All right, you guys, that's it for today.